I want to take you through some number patterns that are found within this cool trig table. The first ones are these ones that are highlighted here, and it has a 30-degree right triangle. Now the truth is, you and I know quite a bit about a 30-degree right triangle. Let's say the short leg was 5, that would make the hypotenuse 10, and it would make the long leg 5 root 3. Now what these numbers represent is this is the representation of the opposite over the hypotenuse. And so if, of course, if we took this number and divided it by this number, we would get exactly that 0.5 that we see here. To obtain this number, this would be the opposite over, or the adjacent over the hypotenuse. So if we took the 5 root 3 and divided by 10, you would get this number. And then finally, the 0.5774, that would be the opposite, which would be 5 divided by 5 root 3. And remember, any similar triangle to the 30-90, 30-60-90 would produce those exact values. Let's look at another number group that we would recognize. You and I know about the 45-45. Here it is right here. And it also has a sine and cosine ratio and a tangent ratio. Now let's notice a couple of cool things. In this particular situation, sine and cosine are the same. Why would that be? Well, you know, in a 45-45, there are two sides that are the same. So if you were doing the opposite over the hypotenuse, that would be this guy, you would get the exact same answer as the adjacent over the hypotenuse, that would be this guy, because O over H and A over H, and guess what? These two guys are physically the same number because they are the same side. Why would we get a 1 value for tangent? Well, tangent is opposite over adjacent, and if we look at our values again, the opposite is exactly the same as the adjacent, so that would produce a value of 1 every time. Next, let's look at the tangent value. So just down the tangent column. Tangent, you can see, starts at 0 and begins climbing up, and it continues on until we get to this 1 value here, which we've already kind of talked about. And then when it hits 1 at 45, you'll notice that it continues to grow beyond 1. So off it goes into larger values all the way until it hits some really big numbers, and then it gets to be undefined. And this is the guy I want to kind of explain a little bit. So let's put this away for a minute. So tangent represents an opposite over an adjacent. Now the reason I've drawn this this way is because I want you to relate this to something that you would have done in an Algebra 1 class with something similar. This ratio of opposite to adjacent is very similar to something you did when you did rise over run. Notice it's the same comparison of the group. So really what we just learned there is that the tangent of some angle is the opposite over the adjacent, but it also is basically the rise over the run. And in other words, we can say tangent is equal to slope. So when we think of the tangent values and how big they are, we can think of that in terms of the slope of those particular items. Let's look at the numbers now. So we just said that tangent starts at 0, climbs all the way up to 1 at 45, and then continues to climb until eventually it hits undefined. So the idea behind that is that if you have the slope of 0 degrees would be 0, the slope at 45 degrees would be 1, and then the slope of a vertical line, in other words at 90 degrees, is undefined. So if you think of tangent in terms of slope, it makes sense that that ratio can exceed 1 and go all the way up into that undefined or infinity stage. So think of tangent equals slope. The next thing I think we want to notice is the values for sine and cosine. Let's take a close look. Sine starts at 0 and it climbs up, obviously, continues to climb up, 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 up. And how big does it eventually get? So let's look at sine's maximum. Interesting. Sine maximizes at 1. How does cosine work? Well, cosine looks like it starts at 1, getting smaller, 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 smaller. Where does it end up? Let's see where it ends up. So as it comes down, as it comes down, it zeroes out. Isn't that interesting? So what we're finding out is that sine values start at 0 and climb to 1. Cosine values start at 1 and decrease down to 0. Let's first start with why would these values only ever be between 0 and 1? Well, sine of any angle is the opposite over the hypotenuse. Cosine of any angle is the adjacent over a hypotenuse. And the answer to why these values can never exceed 1 is hiding right here in the denominator. This guy will always be bigger than the adjacent, or bigger than the opposite. And so this ratio will always be basically between 0 and 1. Tangent, on the other hand, and remember, tangent does get to be bigger than 1, but that's because it's opposite over adjacent, and nobody has to be bigger in that relationship. But in this relationship, the opposite will always be smaller or equal to the hypotenuse, smaller or equal to. So that's why its maximum value when you get here is either 1, or in cosine's case goes from 0 to 1. Let me do my best to now explain why, not only, so we know now that it's 0 to 1 because the hypotenuse is bigger than the opposite, but why would it go from 0 to 1, in other words, increase from as the angle gets bigger? Why would cosine go from 1 to 0, in other words, decreasing as the angle gets bigger? This little diagram that I have down below here might help us out a little bit with this. So right now, the angle is fairly small, if you can see, again, a tiny angle. And in that environment, you have a couple of things. Let's just keep an eye on the opposite side here. This opposite side is also quite small. And remember, the ratio of sine would be the opposite to the hypotenuse. So right now it would be a small number, small angle, small values. If we were to get a bigger guy in there, in other words, if that angle now got a little bit bigger, which it did, guess who else gets bigger? The opposite side gets bigger. So do you see that that would create a better ratio, a larger value? It would increase as we go. If we get even bigger, if that angle gets even larger, say down here we get quite a bit larger, more like 70 or 80 degrees, well, who's getting bigger? Look, the opposite side is getting bigger. That ratio between opposite to hypotenuse is getting closer to a ratio of 1. And that angle can go bigger and bigger and bigger until it squeezes out to 1. So 0 to 1. Now, why would cosine decrease? Well, let's take a look at it. Again, with a small angle, starting with a small angle, cosine is the value here of adjacent to hypotenuse. Notice it is quite large, and it's very similar in size here. So if that angle was tiny, tiny, A to H would be very close to a 1 ratio. And as that angle gets bigger, look who gets smaller. Our friend adjacent gets smaller as we increase the angle size. And so now we're seeing, hey, that's why we are in a decreasing mode for this guy. Because as that angle gets bigger, O is increasing, but A is decreasing. So sine is always between 0 and 1 and increases as the angle gets bigger. Cosine will always be between 1 and 0, and it's a decreasing value in that quadrant.